So do you feel like you can find those? End behavior. How do we do end behavior? Guys, this end behavior tells you one thing. There's one thing you need to know. The end behavior is either going to be positive infinity, negative infinity, or go to a specific number, isn't it? Usually if it's a polynomial function, it's going to go to positive infinity or negative infinity. How can we tell? We can tell from using two things. What's the highest power? If the highest power is even, if the highest power is even, both ends go the same direction, don't they? Highest power is even, we're either going to have the coefficient is positive, and the function's going to look like this. If the leading coefficient is negative, then it's going to look like this. And we can tell what the end behavior is from that. Do you get it? So let's take a look at an example of this. This would be the limit of f of x as x approaches positive or negative infinity is going to go to, they're both going up, so what is the limit going to be? Positive infinity, isn't it? This one's going to be exactly the opposite. This guy, if both ends are going down, what is the end behavior going to be for both of these? Yeah, negative infinity. So we only have to check the biggest power. So let's take a look at this guy right here. Does everybody agree that this is the highest power? Second power? So it's even, isn't it? So if it's even, it's either doing this or it's doing this. Now, look at the coefficient sign in front of it. This sign is what? So is it doing this or is it doing this? It's doing this, isn't it? So what's the end behavior going to be on both ends? Negative infinity. See, you can kind of sketch it and see. End behavior is negative infinity, isn't it? All right, so we would write that. So we would say this is going to look like this, okay? It's going to look like that. Because we're looking at y equals negative x squared. We don't care about the rest of it, guys. We're only looking at the highest part of it. So the limit of f of x as x approaches negative infinity. Remember, we always just write these to start with. And we're going to fill both of those in as what? Which way is it going if it's doing this? Yeah. Negative infinity. Because of this, correct? All right. So look at what happens if it's odd. What if the highest power is odd? What if the highest power is odd? It's going to look like this. If the coefficient is positive, it looks like this. If the coefficient is negative, it's going to look like this. So can we see what's happening to those? If it looks like this, guys, to the right it's going where? Positive infinity, and to the left it's going negative infinity, isn't it? That's if the power coefficient is positive. If the coefficient is negative, it flips over. And to the right it would be going where? Negative infinity, and to the left it would be going to positive infinity, wouldn't it? So you just have to look at it. So let's look at this guy. X minus 1 cubed. So my function is y equals x cubed, isn't it? Doesn't that cube go there? That's all I need to worry about. I don't even need to worry about this minus 1 part. I just have to look at the highest power. So this is odd, isn't it? Odd and positive. So it's odd and positive. So it's going to look like what? That, isn't it? So then we write our two limits of f of x as x goes to the right. What is this guy doing to the right? This means to the right. So what is it doing to the right? Positive infinity. Okay? So this is going to infinity because this is this end. Now, the limit of f of x as x approaches negative infinity. This, guys, is looking at this end, isn't it? So which way is it going? Negative infinity. So you just look at the lead coefficient and the highest power of the highest power, and you decide, is it even and positive, even and negative, even positive, even negative, odd positive, odd negative. That's simple. Okay? So let's look at this guy. What about this guy? It's got a cube. Does anybody want to say this is odd? What do I have to consider? They're sneaky on you sometimes. I've got a cube here, but I've got a what here? Another one, don't I? So we have to consider this whole thing. X cubed times x is what? X to the 4th. So this is even and what? Negative. So even and negative is going to look like what? Isn't it? So even, negative, our sketch would look like this, wouldn't it? Our polynomial would be negative 1/2 x to the 4th. And then we're going to write our limit statements. So what do you think so far? What did you fill in to both of those? Negative infinity and negative infinity. All right. I want you to figure this one out. What is my highest power? What is that going to look like? We're going to have to take this and distribute there, won't we? So what will I write? Yeah, negative 3x to the 5th. So it is what and what? Negative and so sketch that one. What is negative and odd going to look like? And then write your limit statements. Did you make this your sketch? Okay, so write your limit statements. The limit of f of x as x goes to the right. The limit of f of x as x goes to the left. Correct? Okay. So if that is my graph picture, what do I fill in? As f of x goes to the right, what goes here? Good. Negative infinity. As x goes to the left, what goes here? Positive infinity, doesn't it? Negative infinity, positive infinity. Okay, so I think this section is too big for one day. I think if I push you, we could probably get through the last of it, but your brains are going to explode. So, what I want you to do is I want you to do 1 through 3 on your exit ticket. Turn those in, and then I want you to do through problem 12 on your homework. 1 through 3 on your exit ticket, 1 through 12 on your homework. I'll write it right up here. 1 through 3 on your exit ticket, that's the small one, right? And then 1 through 12 on your homework. And we will finish this up next time. Okay? Huh? Oh, you got 2 of them? And just turn your exit ticket in when you're finished. I will put the tray out for you. Right here. How about I put it right here? Yes. Yes. That's a great way to think of it. She just asked me, she was talking about jump discontinuity, and I love this analogy. She said, is it like the square rectangle thing? You know, a square is always a rectangle, but a rectangle is not always a square, right? So a piecewise function is, a jump discontinuity is always going to happen with a piecewise function, but a piecewise function is not always going to have a jump discontinuity. So you look first at whether it's piecewise or not. If it's not piecewise, then it can't be jumped. And then if it is piecewise, then we check those points and see can it work. Okay? All right.
We're doing 1 through 3.
Yeah, just 1 through 3. Start by factoring. And that's what we're going to work on next time I think we're going to do a little factoring review for some of you who think that anybody think their factoring is a little weak? Be honest. Okay, yeah, most everybody in this room. That's fine. We've got a little extra time if we're just going to do 1 through next time. Finish it up. And we're going to work on some factoring in class and see if we can't get your factoring stronger. Can't hurt anybody. back if you borrowed one. Thank you. Yes. Appreciate it. Mark you off my list. Tray. Black tray.
She don't.
Yeah. You'll be all right. You'll be all right. I promise. It will be okay. Black tray. I usually have it sitting up here, but I've got a demo thing sitting up there. Bye guys. Have a great day. Do I take late work? Not typically, no. Why? What's going on? You don't have your homework?
No.
Is there a particularly good reason?
I didn't have time to do it this weekend. I was doing family stuff all weekend, so I wasn't at home. And then I got home late last night, so I couldn't.
Are you in band or?
No, I was still doing family stuff. Not over the weekend, but yesterday.
It's hard. Whoa. It is the slope. The only thing we have to see here is that it is the slope between two particular points, okay? Between two particular points, we've got the slope. So we just have to, what's going to happen here is they're going to give us a function instead, and they're going to give us our x's, and we're going to have to plug in and find our y's, okay? So we want the rate of change over an interval. Guys, when they give us an interval, they're giving us x's. Do you notice that this is not a coordinate point? Not a point. Make sure you write that down because that's what ends up happening is people think that's an x and a y. It's not. That is an x and another x. This right here is x sub 1, and this right here is x sub 2. Now, they give you a whole bunch of math speak. They're talking about a secant line. Everybody remember secants? Does anybody remember secants from geometry? It's a line that crosses a circle, and it touches on two places of the circle, doesn't it? Turns out a secant line is any function where it crosses through and touches at 2 points. So this guy's right here is called a secant line. Because it's touching this wavy function here and here. Okay. Well, the two places where it touches, guess what? This is an x sub 1 and a y sub 1. And this is an x sub 2 and a y sub 2. It is 2 points. If we have 2 points, then we can find the slope of that secant line. That's what the average rate of change is. Anytime we have a line, we can find the slope. So that's what we're doing. This is our change in x. This is our change in y. Right here is change in y. And right here is my change in x. And we're going to use those numbers to find it. Average rate of change, that's AROC. Average rate of change is delta y over delta x, which is slope. We're simply going to take the function, this is y sub 2, and we're going to subtract y sub 1. X minus c, this would be my x sub 2 minus my x sub 1. Now do you see that it really is just the slope formula, isn't it? So really all we have to do, if they give us two x's and they give us the function, we just have to find the two y's that go with those x's. Does that make sense? So let's do that. If we have an x sub 1, the first step is to plug in x sub 1. So we want to find f of x sub 1, which is going to be f of what? What is my x sub 1 value there? It's 1, isn't it? So we want to find f of 1. Well, we're given a function to plug it into. So if I find f sub 1, I'm just doing substitution, aren't I? We get 1 cubed, because I'm plugging in here, minus 3 times 1. So what is that going to be? What's 1 cubed? So this becomes 1 minus 3, which is what? Negative 2. So my first point, so this is y sub 1. This is y sub 1. In other words, I want you to write this as a coordinate point. This is the point 1, negative 2. Okay? So we found the first coordinate point we're going to plug into our slope formula. Now guess what? We have to do the same thing, but this time instead of plugging in 1, what are we going to plug in? Yeah, the other x value they gave me, which was 3. So now we're going to plug in f of x sub 2. This is going to be f of 3. So what is that going to give me? 3 cubed minus 3 times 3. Again, we're plugging in for our x. We're plugging in here and here, aren't we? So 3 cubed is 27. 3 times 3 is 9. So what is 27 minus 9? 18. So we have our second coordinate point. So now this is y sub 2. I'm sorry, y sub 2, not y squared. So now we have the coordinate point 3, 18. All right? So now we find the slope. IROC, average rate of change, is y sub 2. What's y sub 2? Minus y sub 1. X sub 2. What's x sub 2? 3. Minus minus x sub 1, which is what? 1. Minus the negative becomes a positive, so we have 20 divided by what? Which is what? So the average rate of change is 10. Guys, this isn't hard. It's just making it a little bit harder because we actually have to find our y's given a function this time. Okay? So let's practice. Average rate of change, not so bad. Is that all they gave us was 1 practice point? Huh. I don't be liking that. Hang on. Well, we'll roll with it and see. I guess they figure you know how to substitute and you know how to find the slope, don't you? How many of you feel comfortable subbing in? Good. How many of you feel comfortable finding the slope? Okay. So I guess we didn't need that. All right, so comparing functions and interpreting graphs. So how do we compare two different functions? Guys, we find we can compare two different functions by looking at the different features of their graphs. Okay? We want to find y values where a function is positive, where a function is negative, and where a function is 0. It says write a math statement for functions f and g to represent each verbal statement. Use function notation as well as appropriate symbols. All right. So what does it mean to say we have this point x0 located on the graph of f of x? Basically, they're asking you to take and say x0 represents what in function notation? This is giving me a what? It's a y value, isn't it? Guys, we need to think about this. we normally say f of x equals y, don't we? Well, we know one of those, so basically what it's asking us is plug in. So this is saying that f of x, because we don't know that, do we, is equal to what? Gave us our y value, so it's equal to 0. Two functions f and g intersect at a given point. If they intersect, what does it mean for two functions to intersect? What do they have in common? What do they have in common where they intersect on the coordinate plane? Where they cross, that is the same what? Point. That is the same point. If that is the same point, then they share an x and a what? A y. So if we have f of x equals y and g of x equals y, if two things equal the same thing, they both equal y, don't they? So what does that say about f and g? They're equal. So that's what we can say. F of x equals g of x. The two functions are the same at that point. Make sense? A point lies above the x-axis on the function of g. If it's above the x-axis, what does that tell me? Above and below, is that an x value or a y value? It's a y value, isn't it? So what is it telling us about the y value if it is above the x-axis? What do we know about all the y values above the x-axis? They're all what? They're all positive. Okay, so what does that mean? We can't just write g of x is positive. How do we write that in math speak? Positive means it's greater than what? Ah, and that's how we say it. We say g of x is greater than 0. Yes? Okay. So now take what you understand now and say a point lies below the x-axis on the function of f. So how are you going to write that one? Yes. F of x is less than 0 because below the x-axis is negative. The whole graph of f lies below the whole graph of g. I'm sorry, above. I said below. The whole graph of f lies above the graph of g. If f is above g, what does it say about these values versus these values? Greater than. So f is then g. F of x is greater than g of x. So now you ought to be able to do f. F lies below the graph of g. F of x is what? Yeah, less than g of x. Okay. So that's a general comparison. Now, let's look at this. Multiple representations. You know, we can just talk about functions, but we can also look at functions on graphs and tables. So how do we get values off of, if we don't have the function itself? Normally we've just been plugging into the function, haven't we? We've plugged into an equation, we plug in an x, we get out a y. Well, what if we don't have the equation? What if we're given a table or we're given a graph? How do we get a value off of a graph? It says find the value of 3 times 2 times f of negative 3, so we're going to fill that in, minus 4 times g of 0. We want numerical values to plug in there. So what we have to do is we have to figure out what's going on. What is the function? F is this guy, g is this guy. So let's start here. F of negative 3. That's telling us when x is at negative 3, what is y value that matches that? That gives us a function, doesn't it? Does everybody see that? So what is this y value? It's 4. So guess what goes in here? 4. We're just reading, given the x value, we're reading the y value off of the graph that matches it. That's all it's asking you. So we know that this guy right here at -3, we're going to go up here and we're going to go over to 4. So we're going to plug in 4 there. Now, we can't use that graph for G because G is on the table. But that's even easier because now it's saying if the x value is 0, what's the corresponding y value? So we go over here and we say the x value is 0, so what's the corresponding y value for that? -3, isn't it? So that's what we do there. Since this is g of x, g of 0, we know is -3. Now we just work it out. Now it's just a calculator problem. What is 2 times 4? 8. -4 times -3? 12, right? What's 8 plus 12? So 3 times 20 is? So that's the answer. Now, let's look at B. It's trying to make it even harder. It says, given h of x is ax squared minus 4x, for what values of a is h of 3 equal to f of 2 minus g of 3? So the first thing we have to do is figure this out. Can you find what f of 2 is? Look on the graph. What is f of 2? Yeah, f of 2 is 6. So this is 6. Minus g of -3. What's g of -3? We go over to the g. G of -3 is 1. Now we have to find h of 3. So what is h of 3? We take a 3 and plug in here and here, don't we? So that gives me a times 3 squared minus 4 times 3, doesn't it? Do you see how we're gonna be able to find a? What is 9, right? So this becomes 9a minus what? Equals 5. Can you solve that for a? So this is not a hard thing to be able to do. This is just a thing that it's just several steps, isn't it? That's precal. It's bringing everything together you already know in a different way. So how do I solve this? Add 12. So we get 9a equals 17. Now what? Divide by 9. Divide by 9. So we get a is equal to 17 over 9. You do not have to turn that into anything other than a fraction. Okay? Now, that's how we use tables and graphs. So let's do it a little more. Let's look at all the different properties. So I have 2 graphs here, don't I? Now I'm going to be nice to you and I'm going to actually color one of them because I think they're hard to tell the difference between. So let's make one of them yellow. Let's make g of x is this yellow guy. So you can do that if you want to. I'm just doing it, make it easier to tell the difference between the two. Doesn't that make it easier? Yeah, it does to me too. All right. So the first thing it wants is the domain of each function. So what is the domain of this function? Of f of x. F of x is my black function, isn't it? All right, so left and right, what's the function doing? What's it going towards? Negative and positive infinity, right? So the domain of this function is from negative infinity to positive infinity. All right, so now I want you to look at the yellow function there. Look at g of x and tell me what is the domain of that function. What do you see on the ends of that function? Arrows, right? If you see arrows on the end of that function, what is it going to tell you about the domain? Yeah, from negative infinity to positive infinity. All right. Yeah. This arrow says this guy's going to keep on going this way. This arrow says this guy's going to keep on going this way. Oh, yeah. So negative infinity to positive infinity. I know it's going down and up, but that doesn't matter. It's still going to the right. It's still going to the left. This is not asking you the end behavior. This is just asking you for the domain. And that always reads from left to right. Okay? Now, values of such that f of x equals 0 and g of x equals 0. What is this really asking me? If this is the y, isn't it? If the y value is 0, where are those points located we're looking for? On the x-axis, isn't it? So this is asking me, anytime you see 0 here, it's asking you for the x-intercepts, isn't it? So maybe we ought to, see, this is what I'm talking about doing these right here. Tell me I'm looking for the x-intercepts. So let's look for f of x. Where are the x-intercepts for the f of x function? Where does the black function cross the x-axis? At x equals what? Where? -8. Let's look at this guy. Where does it cross the x-axis? At -9, doesn't it? That's 2, 4, 6, 8, 10's here, so 9's here, so -9. So x equals -9. Now, where does the yellow function cross the x-axis? Yeah, right here at -6, doesn't it? So this is x equals -6. Is that the only place? Where else? Crosses here, doesn't it? Where else does it cross? Crosses somewhere else, doesn't it? So at 11, 12, so it's going here. And now it's going to keep on going, isn't it? And it's going to cross where? I'm thinking it's going to keep going like this, isn't it? It's got to cross again, doesn't it? So we have to kind of continue it out. So that's 11, 12, where? So also at 13. Okay? So if you have to, you might have to extend the graph out a little bit. All right, so let's look at the next one. Where are the values of x such that f of x is equal to g of x? Now, we just talked about comparing. Where are these two functions going to be equal? Where they what? Where they cross. So where do these two functions cross? They cross here, they cross here, and they cross here. So we need to figure out those 3 points. So where are those? Where's this first point at? Where's this guy? Yep. -8, +2. Where's this point at? It looks like it's at about what? 1.5, 5? Okay. And where's the next one? Seven, 3? Now it says values of x, so maybe we ought to specify that it would be at -8, 1.5, and 7. Okay. Now we get to the fun part. Where are the values of x such that f of x is greater than g of x? What is it asking me? Where is the f function above the g function? In other words, where is the black function above the yellow function? So let's highlight that. Where is the black function above the yellow function? This chunk is above it, isn't it? And then here, would you agree? That's where, I don't know if how well you can see those, but do you see? That's where the black one's above the yellow one, isn't it? So it wants to know the values of x, where that happens. So where does that go from? From where to where? So that's from here all the way to where? Here? So from -8 to what? 2. That's not quite 2. It's here. So it's at 1.5. Isn't that what we decided? It was about 1.5. So from -8 to 1.5. Okay? And then where? Where is this guy? Yeah, from 7 to infinity. So we'll put a union in between that because we get 2 intervals. That union symbol helps us realize that those aren't points, doesn't it? Okay, so now let's try the opposite. Where are the values of such that f of x is less than g of x? So now what are we looking for? Where the black function is below the yellow function. All right, so let's highlight those. Black function is below it. That would be here and where? Here, wouldn't it? So where are those two? From -infinity to where? Okay, so that's the first. From -infinity to -8. Union of that with where, from where to where? Where's the rest of it? From 1.5 to about where? 7. Good. Y'all have got this. So we're just checking the x values, aren't we? And union of that with 1.5 to 7. Now, what is it asking me for f? Where are the values of x such that g of x is greater than 0? So that's, now I'm just looking at the yellow function, right? And I want to know where the yellow function is above what? The x-axis, yes. So where is this guy above the x-axis? So I'm going to do a little, let's do this in red this time. So where is the yellow function above the x-axis? Here and where? All the way until we get to where? Here. So what are those intervals? From where to where? -infinity to -6. Good. And from where to where? -2 to where? Where? Yep, to 13. Good. Some of y'all are seeing it. Okay. So now what is it going to ask me? It's asking me where is f of x less than 0. So what are we going to highlight this time? Where f of x is what? I'm running out of colors, aren't I? Here we go, black. Well, I'm looking for where the f function is what? Below the x-axis. So where is this guy below the x-axis? Only, as far as I can tell, only right there, isn't it? Okay, so only right there. So what is that interval? From where to where? From -infinity to where? What is that value? -9? Okay. So from -infinity to -9. All right. The values of x such that f of x is increasing. What does increasing mean? Where is the value, where is the f function going up? So I'm gonna have to pick some more colors here. Let me see if I can find a different color. There we go, pink. So where is the f of x function increasing? It's increasing here, isn't it? It's going up there, right? Where else? Going up here. And it's going uphill there. So what are those intervals? What's this first interval right here? Yeah. So this one is from negative infinity to negative 7. Okay. And what's this interval? Negative 4 to where? 0. So this one's from negative 4 to 0. Good. And then what's this interval? From 4 to where? Infinity. From 4 to infinity. I feel like some of you got this. You can read these. If you could figure out which part of the graph to highlight, it's not so hard to read off the x variables, is it? So those three things go here. So we said from negative infinity to what? Negative 7? From negative 4 to 0. And then from 4 to infinity. Good. All right, we've got 4 more. Where is g of x constant? What does it mean for something to be constant? What does constant mean? Doesn't change. Stays the same. So constant means it's what? The y value is going to be not changing, so that makes it flat. So where's the only place where either one of these is flat? Right there. So what is that interval? Negative 1 to where? Positive 3. We read down to the x-axis, so this is negative 1. Read this down, this is 3. So we know our interval right here is from negative 1 to 3. Good. You see what I mean? If you can identify what the question's asking and find that chunk on the graph, you're home free. So from negative 1 to 3, it is constant. G, decreasing. So G is the yellow one. So where is G decreasing? I feel like I ought to just erase everything, and I'm going to erase mine so that I can just look at all of this. Where is G decreasing? Hang on, it's hung up. I'm gonna have to bring it back up again. It flipped out on me. I had too much stuff going on. So where is G decreasing? Where is it going downhill? See if you can identify that for yourself. Where is it going downhill? Where else is it going downhill? Do y'all recognize that it is also going downhill here, isn't it? Now what happens? Now it's going uphill, right? It's going uphill. Now it's going flat, and then what happens once it gets here? It's going downhill again. So this chunk over here, and it's just going to keep on going, isn't it? So it's going to keep on going all the way to where? So what are my intervals? What is this interval right here going to be, this chunk? This is negative infinity to where? To here. That whole thing is one interval, isn't it? So this guy is from negative infinity to negative 4. This one was a little harder because it changed functions, didn't it? But it's still all part of G. So then what is this interval right here going to be? Where does it start? Starts at 3, doesn't it? And where does it go to? Yeah. 3 to positive infinity. Okay? So this is negative infinity to, what did we say it was? Negative 4, and then 3 to infinity. All right. F of x is greater than 0. What is it asking for f of x to be greater than 0? Where is the f function above what? Above the x-axis, greater than 0. This part means above the x-axis. This means a straight line. So give yourself some notes. This means below x-axis, doesn't it? Increasing. Going uphill. Decreasing means what? Going downhill. Greater than 0 means above the x-axis. This one means F was below, hang on, F was below G, right? Is this helping to put some little notes in there so when you have to do it, it kind of clues us in as to what we're doing? This guy means F is above G. This means where they cross, right? Does this help? Okay. This is a lot, isn't it? But it's good for you. It's really good for you. Do y'all realize that the more, I know for 99.9% of you in this room, you're never going to use this type of math. It's not about the math. It's about the processes that you use in your brain when you're doing the math. Every time you have to think about something like this, it's a little more complicated. You're making connections in your brain that make your brain more nimble, makes you a better thinker, makes you a better problem solver. When you can take and connect different types of information in different forms, it makes you smarter. And it's not just, then you can take that skill and go from pre-cal class to maybe you want to be a nurse. And you're looking at a set of symptoms that maybe you haven't seen before and put together the right way. Now all of a sudden you can say, oh, hey, this, and this, boom, it's this. You're used to looking at things in different ways. All right, so don't look at the math class as a punishment that you just have to suffer through. Look at it as a way to make your brain more plastic, is what they call it, plasticity. Making more places, more routes in your brain. The more routes you have in the brain, the smarter you are. Okay? All right, enough of preaching to the choir. So what do we say? Where is f of x above the x-axis then? See if you can do this. F of x is above the x-axis. Wow, that's most of it, isn't it? So write down that interval. What is that interval going to be? From where to where? Where does this thing start right here? What is that point? So this goes from -9 to where? What does it mean that there's an arrow on the end here and we just kept on highlighting? Yeah. So -9 to infinity, correct? All right. Values of x such as x decreases. So what am I looking for? Where it does what? Decreases means where it's going down. So highlight or do whatever on your page. I'm going to do mine in blue. Where is f, the function f, going down? There are two places where f is going down. Can you find them? Did you find them? Now, see if you can figure out what those two intervals are, there and there. So what is this first interval here? Yeah. -7 to -4. I don't know why my pencil isn't. Here we go. And what's the second interval? 0 to 4, yeah. Okay. So -7 to -4 and 0 to 4. You know what? I think we've done so much today that I think what I'd rather do rather than factoring, we're going to start with factoring next time. We'll do a warm-up, factoring warm-up. What I want you to do, since we've done a lot of this, is I'd like you to just go ahead and roll into doing your homework. Roll into doing these problems while you're in class with me. We have some time. It's only 9:39. You've got like 11 or what do you have, like 16 minutes in class left? That's unusual. Use your time wisely and start working on the rest of those homework problems, okay? And that way, if you have questions, you've got a table partner to work with, or you've got me to ask questions to, don't you? So working hard while you're doing this. Good job today.